Welcome back. Let's continue making the learning of physical sciences very understandable, fun, and so that every learner or every teacher who's looking at these videos will be able to master the concepts in the sections of physical sciences. One of the sections for today's session is organic molecules, a broad section, of course. In a normal question paper or paper 2, it will be yielding around 50 marks for both structured and the multiple choices. So it's a section that consists mainly in our section now of 3 questions. One that will be based on mainly the nomenclature, the UPAC naming, isomerism, and the like. And then the second one will be about physical properties. This is normally question 2 of a normal question paper, and then physical properties, which will be question number 3 in a normal question paper, and the last one will be your chemical properties. Chemical properties, mainly in this chemical properties we are dealing with reactions. When organic molecules react with one another, then what happens? This is your typical question 4. Fine. Now let's start with unpacking the organic molecules. The first question will be, what is an organic molecule? By definition, organic molecule will be a molecule or a compound molecule that contains or consists of carbon atoms. That is the organic molecules. Now, in this section of organic molecules, because we center around carbon atoms, therefore the center of attraction here will be the atom carbon. Now, what do you know about carbon from the previous grades? We know that carbon is found somewhere in the periodic table. Yes, it's found in group 4. In group 4, the Roman figure 4, or group 14. And in period 2, I think that's what we know from the grade 10. Now this carbon, it has got 4 valence electrons. Very important, 4 valence electrons. And also on top of that, it has got the valency of 4. Now the 4 appears now twice. 4 valence electrons. Remember, the difference between valency and valence electron is that the valence electrons talks about the number of electrons in the outermost energy level, whereas the valency becomes the number of unpaired electrons in the outermost energy level. Therefore, this valency determines mainly the bonding. So now, meaning that now carbon can bond 4 times. That is the valency. So it can bond 4 times, no problem. Now meaning that now if it bonds 4 times, it can bond with the maximum of 4 covalent bonds. That's the case if you talk about the type of bonding. So now the carbon, as we say, the valency is 4, will be 1, 2, 3, 4 in this case. If I've got another carbon, also will be even 4. That one. Now the covalent bonds, in this case, carbon can bond with another carbon to form long chain. A carbon with carbon to form long chains. Fine. And also carbon can form with another carbon to form branches. It can form branches with another carbon. or even ring structure. But in our case, we are not doing ring structures, so the ring structures. So we are confined to only branches and long chains structures. So the rings, no. This is not our line of this section of organic molecules. We exclude that one. And also from these covalent bonds, again we learn that very important, carbon also can combine with another carbon to form single bonds, and can also form double bonds, and can also form triple bonds. Very important in this case. We learned this in grade 11. Now, when carbon forms single bonds, it's when one carbon reacts with another carbon. This will be the single bond between carbon atoms. Double bond, we have this. We can have this type of arrangement with carbons, carbon connecting with another carbon. Again, carbon can bond with another carbon to form triple bonds. This is very important. Now, we used to call them bond orders, to say the bond order in this case is 1. This is it's called a bond order of 1 in grade 11. And then the bond order here will be 2. The bond order in this case will be 3. That is in grade 11, what we were learning now. Out of this, we're going to build a very important concept when coming to the so-called hydrocarbons. So yeah, remember the triple bond, every bond consists of 2 electrons, meaning that where a single bond is involved, then 2 electrons are involved. Where double bonds is involved, then there are 4 electrons. We'll have 4 electrons. Where now triple bond is involved, we'll be having 6 electrons. So a bond, a covalent bond, involves the sharing of this the sharing of electrons. So 2 electrons if they are sharing, then in a bond they are sharing, and then in triple bond, then it means that 6 electrons will be now sharing the 3 bonds, forming the 3 bonds in this case. Sorry. Now, in this section of organic molecules, you will have to know, we'll deal with the so-called the UPEC naming. The UPEC naming in a nutshell, we'll talk about that one. We'll talk about the representation of this one in terms of the names. That names are normally, we talk about the UPEC name of a compound. We'll be talking about the general formulas. So some compound will have a same general formula. We'll talk about the structural formula. Very important, structural formula. We'll explain. And also we'll be talking about the condensed structural formula. Structural formula. And then the last one will be the molecular formula. Those who are coming from grade 11, they know what is a molecular formula. Now, the UPEC name, there are rules that will be following in dealing with UPEC naming. General formula, will be showing you an example here. A structural formula, we show all the bonds. Here, all bonds must be shown. Show all the bonds. In this case, in a structural formula, all bonds are shown, whereas in a condensed, you can show no bonds or some bonds. But in a molecular, it's about the ratio of atoms here. Ratio of atoms. I hope it's understood. So ratio of atoms, then I can talk about the molecular formula. Let's take an example here. That will be now, just out of curiosity, let's say butane. There's an element that we'll learn about where is this butane coming from. But for now, the general formula for butane, to make an example, it will be CnH2n plus 2. And then the structural formula of butane will have 4 carbon atoms. and then all showing all the bonds now with hydrogens, and then this will be the structural formula of butane, and then the condensed structural formula of butane. Therefore it will be now having your CH3, CH2, CH2, CH3. That is the condensed. The molecular formula for butane will be C4H10. So if you want to master this one now, you will be conversant with this throughout this section. With this four, we can represent the name or the general formula or the structural formula or the condensed structural formula or the molecular formula. So please be able to entertain this one. Now, this take us to maybe one concept that will be entertaining is very shortly, which talks about the homologous series. Homologous series. So we'll be now unpacking this soon in the next part of this session to say what really is a homologous series, and then now how many homologous series are we going to deal with, because in a nutshell we need to know at least, we need to know 9, maximum of these 9. All of them, they are 9, and of which now out of these 9, 3 are hydrocarbons, and then 6 are the derivatives of hydrocarbons, or we call them hydrocarbons derivatives. Hydrocarbons. And that now, do you have to know these 3 hydrocarbons? I mean that, why do we say they are hydrocarbons? Because they consist of only only carbon and hydrogen. So that's why we call them hydrocarbons, because they consist compounds that consist of only carbon and hydrogen. They are called hydrocarbons. So we'll unpack this one in the next session of this topic of organic molecules. Bye.